Based on current European Space Agency data, there are over 5,800 functional satellites in orbit, with nearly 31,590 debris objects that have been logged and continuously tracked by space surveillance networks. But what about the rare and curious astronomical objects that may have vanished or appeared on our sky? And what could make an object vanish entirely or appear out of nothing? Could they be alien artifacts? Or from ET? Beatriz Villarroel, researcher at the Nordic Institute for Theoretical Physics, awarded the L'Oreal UNESCO Prize for Women in Science, principal investigator at the Vasco network, joins me to answer these questions and discuss her recent findings. Join us as we get rebelliously curious. Beatriz, thank you for joining me on Rebelliously Curious. So you do a plethora of things. You are a woman in science, but you also are a researcher at the Nordic Institute for Theoretical Physics. You are also a recent award winner from the L'Oreal UNESCO Award, and you also are the head investigator of the Vasco network. You do so many things as a woman in science, and I appreciate that. And how do you sleep at night? And how do you even have time to sleep at night, I should say?
If to be honest, I don't sleep much at night. But I think one of the tricks I've been always doing is to try to do only the things I really like to do. And I think that's something that is very, very important. And I would say, especially for women that are doing science, and that is to learn to do the stuff that you like to do, follow the research leads that you are interested in, because then things become much easier. Work doesn't feel like work when it's your passion or your hobby at the same time. And if you simply do the stuff that you like to do, you will have much more fun and you will manage your time in a much wiser way.
Yeah, it's great advice. It's true. Yeah, I think you have to follow your passion and you have to follow your love and anything you do. I agree. And I'm really proud to see women doing more in science because they should be. And I'm glad that there's obviously more of an acceptance and there's funding and women are really taking a lead. And it's beautiful to see. You do so many things, and one of the areas of studies that you have in theoretical physics, but also looking at vanishing star and anomalies. Can you break down the area of science or the area that you're studying right now, and why you're studying it?
Okay, so even if I'm affiliated to the Nordic Institute of Theoretical Physics, I actually do more of data analysis and observational astronomy with astronomical images. And so what I really, really like working with is the searches for anomalies, because by searching for weird astronomical objects, you can actually learn a real lot. You can find something that is absolutely crazy or that you thought was crazy, and then you actually can maybe sort out that this is a rather normal phenomenon, or you might find something that you at first sight you don't know what it is, and then you learn that this is something super cool. And maybe you can even find some type of SETI candidates, like candidates that you can follow up for, such as for extraterrestrial intelligence research, like that you could say, okay, hey, this one we're going to take a careful look at just in case. So I'm very, very interested in searching for weird anomalies. And if you think of it, a lot of the astronomical objects that we know of today, when they first were discovered, one saw an anomaly. For example, the quasars. Like all astronomers know what quasars are today, and that is that you have some super luminous objects in the course of galaxies that are very luminous because they have a lot of accretion of gas that falls upon a supermassive black hole. But when they first were discovered, like in 1963, one didn't know what it was. One saw something that looked like a star. It looked like a star, and it shone it had a very strong shine. Do you say so in English?
Right. Yeah. No, that's great. Yeah.
But the object that looked like a star seemed to also be extragalactic. It seemed to be outside our own galaxy. And that's how one discovered a quasar, that it was a very, very mysterious spectrum associated to this star. And every time we find an anomaly, we push science further. And that's why I like to search for anomalies.
I think that's amazing. And how do you go about searching for an anomaly? Like, where do you start with that? It's such a massive sky, we have such a massive universe. How do you even go about, where do you start? And then kind of break down that process for me.
So I have a project called the Vanishing and Appearing Sources During a Century of Observations project, also called the Vasco project. And we are about 40 people from different disciplines. And we are trying to find things that either has vanished from our sky or appeared in our sky in some weird way. And we do this by comparing images from 1950s with the images from today. You have like 70 years in between these images. And we were hoping to find a vanishing star, like a real star that has vanished entirely. We started finding other weird things instead. But it's a very, very fun project because we do this together with citizen scientists. And we do it in particular with citizen scientists in Algeria and Nigeria. So it's super fun for us.
And I have to ask now, you said you found weird things. What are these weird things that you're finding, or what are these anomalies that you're finding that you would consider weird?
So I have one favorite. Let me show it to you.
I'd love to see that. What are we looking at right now?
So this is an image from the 12th of April, 1950. And this is an image, I think, from 1986. I think it's written there. And or 1996, maybe it is rather. So in this image, in the green circles, you can see 9 star-looking objects that are there on the 12th of April, 1950, but they are no longer there in this image. The fact is that if you look at an image taken half an hour earlier, right, they are not there either, and neither 6 days later.
Wow.
So, and they look all like very star-like, and the brightness profiles are typical of stars. And what makes these 9 objects appear and vanish within half an hour? Now, that is one of my favorite anomalies, because we don't know if it's real. One of the most boring explanations is that these stars are no stars, but some type of plate defects that by coincidence, by pure coincidence, all of them, these plate defects would have very star-like brightness profiles, which is kind of weird that they all would have this coincidence in this little image of the sky. Maybe some type of contamination, nuclear fallout can produce this kind of plate defects, or it's actually a real astronomical observation. But then it's kind of super weird because we don't know any astronomical phenomenon that would create this kind of effect.
Wow. And you said that one plate, when looking at one of the panels, 30 minutes later, it was gone as well. So it wasn't just over a course of years, it was over a course of minutes.
Half an hour. So the only way how I could imagine this happening would kind of not be with anything astronomical, but let's say if today you have lots of satellites and space debris, then you can have glints and sometimes appearing like multiple glints in a small image. And that would be totally normal today, but this image is from 1950, 7 years before Sputnik 1. So,
wow.
So that's why it's so important to find out whether it's a real phenomenon or whether it's some type of very unusual defects.
Yeah, and you brought up Sputnik 1 because before that, that was one of the first satellites that was ever launched. So the relevance, I guess the importance of that is that there was no other space junk or any debris, if I'm correct.
Exactly.
So right. So what we're looking at is something that wouldn't have all this mass amount of satellites or space junk or, Elon Musk sending up the Starlink or anything like that. So I think that's really unbelievable. And then how far is that close to Earth is that image?
Well, we actually don't know. We have no clue. But it's should be pretty far away because they are focused. And well, if it is real, I can't say how far away it is. But one guess that we have done is that it could be in a geosynchronous orbit around Earth, so it could be something like 40,000 kilometers. At 40,000 kilometers altitude or 36,000. So it would be pretty high up and not sent by us, but I don't, I will say like this, one needs to start with the most boring explanation that it's maybe some type of defects, and we are starting there, and we're trying to figure out how we can test this in a very, how can I say, in a more accurate way. Anyway, it's one of my favorite anomalies, because you can find this type of weird things in the photographic plate surveys that people never thought about. And maybe it's some type of new astronomical phenomenon, or some new type of sky phenomenon that nobody knows of, that has nothing to do with any alien objects or so, but simply because they are very, very rare, and we would not see them on the sky today because the sky is too contaminated.
Right.
And that would also be cool if it's some new type of astronomical phenomenon or new type of atmospheric phenomenon that one just doesn't know about. I
Right.
would
And
find it exciting.
very exciting. Have people considered you in comparison to Avi Loeb, like a female version of an Avi Loeb? Because I say this, I say this because we hear, we know that, and you are working alongside the Galileo project for that we're seeing, which I think is amazing. And we need, I think Avi needs more scientists and more people within that space, and, helping and looking and observing what's happening. But he's also looking for extraterrestrial artifacts as well. What's the difference between what you're doing and then what Avi Loeb's doing at the Galileo project? And maybe how are they similar?
For me, he's a very, very inspirational scientist. I think he's courageous, he's brilliant, really, really brilliant. So I'm like always super happy to see what he's doing, and all his ideas for the Galileo are very, very inspiring for me. Now, Galileo is trying to look for like anomalies and UAPs, like now with new instrumentation, and they are trying to use or they are using an artificial intelligence. They have a fantastic instrumental setup that they have built and like fine-tuned in order to search for UAPs. Now they are working with the sky as it is today. In the Vasco project, when we see these things, we're looking at the old sky, the sky without the satellites, the sky without all the human contamination, because we have like now in these high altitude orbits in space, we have something like 30 million of pieces of reflective metals or other type of objects that are there, that are giving off all the time reflections and are larger than 1 centimeters. We have an enormous amount of contamination, and Vasco basically looks back in time, and Galileo looks right now. So if you want to actually confirm something right now and get a spectrum and get really good imaging, is the Galileo project. But what we can offer is an uncontaminated view.
Yeah, I think it's wonderful how you're doing this past and present, and you're looking for these, alien, ancient kind of artifacts. And the amazing part is that, maybe we'll see something in a panel that you'll capture. And then one day, maybe would we see something similar and present and be able to compare and contrast them and look at that data, because you're looking at the past and he's looking at the present. Do you think that you'll find something that might be similar, where you can say to Avi, like, look what we found? And one day he can say, like, look what we found, and be able to maybe not figure out obviously where it's from, but have a little bit more understanding, obviously with time too being a major factor of that.
Absolutely, because if we search like we're doing the searches now, we can do some key predictions, and we can send them to Avi and the Galileo project, who probably will be very excited and might look for these type of events in their data. And I see these projects simply can be very complementary to each other in the way that we can submit our results to them, and they can take a look, and we can give each other feedback. I think it's very complementary.
Yeah, it's fabulous. Now, what about SETI? Have you talked to SETI with your recent research, and have they said anything to you about it, and do they have an interest in it as well?
I don't have much of communication with the entire SETI community regarding this, because there's not so much of interest into the near Earth SETI. So I usually try to talk more with my colleagues who are more interested into the UAPs and so on. We are a minority so far in the SETI community, but I think it will change with time.
Yeah, and I hope it does too. It'd be great to see more organizations working together. Micah Hanks recently did an article entitled Evidence of Non-Terrestrial Objects Surveilling Earth Could Be Revealed in New Research Effort. And so you were quoted in this article, and I will link this above as well, so anyone who wants to read it can. The question is about aliens and ET, if they've been surveilling Earth for a very long time, or if they have from the past, and what that could possibly look like. How might we would detect evidence of these technologies then, in your perspective, of how we'd be able to detect this if they have been surveilling us for a very long time?
So if we go back to this image,
yeah,
like I was mentioning, that you could have like multiple stars appearing and vanishing in the same image. So imagine now if some of these stars would be aligned. Let's say that they would be, if you would have something orbiting the Earth, sometimes you can also see, not in all cases, but that several of them fall upon a line. And that's one of the things how we could separate that from the idea, from the possibility of that they would have defects. And because if you have defects, these are going to be randomly placed on your plates. Now, if you have something where they all perfectly lie on a line, that would be more indicative of that you have something moving in an orbit around the Earth. So what we simply can do, like with the vanishing and appearing sources during a Center of Observations projects, we have been looking for these stars that appear and vanish over several years now. We can take the lists because we already have them. For example, there came out a paper 1 month ago by my colleague Enrique Solano, where we have been looking for like this type of transients. And what you can do is to simply look for take the coordinates and look for those that align on a line. And we have been working on this. We have a preprint out and the article is currently under review, where we have been looking for this type of examples. We found a few interesting examples that we still don't know if they are real or not, but they are quite unlikely. So we have to examine them more in detail. So we're having fun with that.
Wow.
And let's see if it survives the review process.
Right. I want to go back a little bit to the citizen science project. And there's 40 different types of astronomers, scientists, and people that are working in it. How do you pick these people? How do citizens get involved? And how do you pick them to be able to help you on this research effort?
Everyone are allowed to join us. And
Okay.
usually it's been like when people contacted me or that we have started up collaborations. So everyone are allowed to join Vasco.
I did see though online that you have this website too, that you can go and you can look at the panels and you can help do some actual research. And I'll show what these panels look like too. Can you break down how somebody will be able to go on and help and look at these images and then send that data back to you?
Sure. And we have this web page where I can go and I can compare an image from the 1950s with an image from today. And you can look if the central object in the left image from 1950s is missing in the right image. And one can click there and select different options. You can play around with the alignment of the image. Apologies, my cat came in here. And one can also examine many more images there if one clicks on the inspect button. And one can also contact us if one finds something very interesting. Please write to us and we can discuss, and we will also be interacting with the citizen scientists. Now we have also focused extra on 2 communities of citizen scientists that we have enjoyed working very much with. And one is the Serious Astronomy Association in Algeria. That is
nice.
by Professor Jamal Mimouni. That is also the head of the African Astronomy Society. And the other one is a community of researchers and students in Nigeria at the Basic Center of Space Science there, led by Emeka Dom. And then these 2 groups have been doing extra much of Vasco citizen science activities and workshops and so on, which is super fun.
That's amazing. Have you had time to go to Nigeria to see them or to meet the people that are working on the project?
We're going to meet for the first time live in December, because we are planning to make a real life workshop we couldn't do during the pandemics, and there has been a lot of struggles with the visa and so on. But in December, we will finally meet in real life, and I look really much forward to it.
That's exciting. I like to have you back on the show along with maybe some of the students that have been doing some research with you, because it'd be amazing to see that perspective. And I also just like to see that cultures are working together in multiple different ways to find, to find answers, which I think is really beautiful.
I think it's also so important for me that SETI research can be done not only by the richest institutes, because it has only been done by the absolute most Ivy League institutes that can afford it. And I think this is a question that belongs to everyone, because it belongs to all cultures and all religions on the planet and all nations. I mean, why are we here on Earth? And I find it important to try to make SETI available over the whole planet. At least for me, it is.
I think that's beautiful. You're right. And it's not just, science isn't just for people that obviously have more money or wealth or rich institutes. It's for everybody. And research is for everybody. And this affects us all. So I think you're right. I think having the average citizen and having multiple different cultures learn and research and have their own perspectives, I think is just really unbelievable. And I commend you on that for sure. I want to ask you your perspective of the UAP topic.
Absolutely.
Where are you currently now? We have so much going on about UFOs. Is it something that you follow and take really seriously while you're looking at all the new research when you're doing your own research and your own data? Are you following the UAP topic currently, and have you followed it for maybe years?
Well, I would say I'm starting off like a UAP agnostic, because in astronomy, I have always been surrounded very much by skepticism to it. And at the same time, I must say that I was like many astronomers, or like some astronomers, I have been shocked by the congressional hearings that were made public, and also these what's called the report that came out in 2021 last June. Because it really made me think, like, can I just be dismissing this? And especially when I see weird things in the data, can I really just be dismissing something because of some kind of preconscious biases? And here I find it very important to just investigate. And I think that's the most important thing for us astronomers and scientists is to maybe not say that UAPs are real or assign them a explanation like that it's extraterrestrials. What is important for us is to stop dismissing the topic and stop stigmatizing it, stopping to there is some ridicule towards scientists who are interested in the topic, and I think that's wrong. We need to destigmatize the UAP field, because why would it be okay to look for aliens very far away, but why is one crazy if one looks close to the Earth? I mean, it doesn't make any sense. It should be distance independent, the seriousness level. And I find it equal in the light of all these reports that we have seen in the last year. It's time to just take a serious look at the UAP question. And in the case of Vasco, we are not really working with UAPs directly, but we're looking more for space probes or just remains from metals when we are looking for this kind of glints along a line. Remains of a probe or so. That's not directly a UAP, that maybe would be a broken UAP or something like that from maybe 100,000 years ago. That
UAP space junk.
Well, if aliens sent something here, let's say 500,000 years ago, a piece of it might still be in orbit and we would be able to see it in our data. So even if it doesn't deal with the UAPs as a phenomenon, it still can give us some type of insight if any probe has ever been near us. Well, yeah. So that's where I come from. If you ask me, do you think that UAPs are real? I don't know. I don't have enough of knowledge, information. I can imagine that a lot of the testimonies are real, but misinterpreted. Maybe it's something natural. But I find the question important, and I want to help to destigmatize the research so that people can do a really good try to understand the phenomenon, where it comes from, and explain it, no matter what is the end result, even if the end result is just that it's all wrong, or if the end result is that yes, it is ET and they are here and we're being invaded. It doesn't matter. I think it's just important to destigmatize it all.
I want to ask you my last question too. I'm curious to see if you had way more funding, in the next like 10 years, where would you take the Vasco? Where would you take the Vasco network, and where would you like to see it go?
So right now I'm getting out of funding. So if we say it like that, because I have only like 3 months left of funding. So that's my current situation. I'm going to try to apply for funding, but there hasn't been given any SETI funding in Europe so far. So it's going to be a big challenge, very big challenge, especially the way how the kind of SETI we're doing. But if I imagine if we would have 10 years more of funding, I would really want to go on this track that we are doing with the glints and looking for probes near the Earth. And together with a colleague, we have now been working on developing a program for this that I cannot tell more about. But I hope we will be able to land some type of funding for the research program we are developing, because we are very interested in making a very, very deep look into the question whether there are probes or alien probes near our Earth or in the solar system. And we are going to keep working on that.
That's awesome. Beatrice, that's our time, but I want to say, as I say to all of our guests, thank you for being rebelliously curious with me. And I look forward to having you back later on, hopefully potentially in the new year after you go to Nigeria and do some research with some civilians there. So thank you again. And it's great chatting.
They're coming to Sweden, actually.
They're coming to Sweden. Oh, okay. Yes. Even better. Like even better. But thank you very much.
Thanks a lot.